So for our action potential, I'm going to be using this picture from the book, so I hope they don't mind. But this is a multipolar neuron, and this is actually after when threshold has been reached. So usually the charge of the cell will not be -55, but -70. And what this is showing is this is the neurotransmitter being released, and this causes ligand channels to be open, which lets sodium in. So to map out kind of the membrane change over time, so the membrane potential is the difference between the charge inside and outside of the cell. So right now, since you have more potassium inside the cell, your resting membrane is at that -70, and then once these ligand channels open, it moves to -55 in this example. There we go. So at -55, this is your threshold, and what that means is that these voltage-gated sodium channels here in the trigger point of the axon will open and allow more sodium to enter at a faster rate. So with the multipolar neuron, like I said, you have these ligand channels at the axon. Like this is the body, these are the dendrites, and they're here in this like postsynaptic cleft. And then you have your voltage ones here in the trigger zone. And then as sodium enters the cell, it becomes more negative, or sorry, it will become more positive, meaning that it will eventually reach to around negative or +30. And again, this is a much faster process than with the ligand channels. Okay. So then once a negative or that +30 is reached, at threshold the potassium channels are open, but they are slowly opening. They're not as fast as the sodium ones. So at around negative or around that +30, the sodium channels will begin to close and let room for the potassium ones to open. So potassium is then leaving the cell. So you see Na going in, and then potassium will go out. And then because of these changes and these channels opening, these action potentials will trigger the channels down here to open up. And that's how it travels down. So when these potassium begins to leave the cell will become more negative, and it'll actually move past -70 to around -85, I think we say, or just -80. So again, once it comes down to this threshold, the channels will close, and again, the potassium ones are very slow to open and close, so that's why it overshoots the resting membrane potential and goes to -80. Once all membranes are fully, once all channels are fully closed, it'll then kind of resituate itself and return back to this -70 of the resting membrane potential. And the change in the membrane potential is known as an all or nothing response, for if the neuron responds to a stimulus, it responds completely or not at all. The greater intensity of the stimulation produces more of these impulses per second, not just a stronger impulse. So overall, the neurotransmitters get released, they trigger the ligand sodium channels, which increases sodium into the cell, that causes the resting memory potential to become more positive. And then once it reaches this threshold, the voltage gated channels will open, both sodium and potassium at the same time. Sodium opens up faster, so the cell will continue to increase in charge, and then once the potassium ones are open, the sodium ones then close, and then the potassium ones are opened at that 30, closes, and the cell begins to become more positive. And then once that threshold, -55, is reached again, channels close, and the cell will return back to the -70 resting membrane potential once all cells are, or once all channels are completely closed.